Hello, this is Mark Werwath. The next topic in the series of technology strategy, special events and special topics is a topic called industrial symbiosis. The term symbiosis is a term from biology. It talks about how one species has an intimate relationship, close relationship with another species that is mutually beneficial. So these processes of waste from one species might become part of a nutrient cycle for another. So you see here a classic example in tropical settings in the tropical fish arena, but we see this in many other situations. I'm going to specifically talk about how industries can take advantage of it, how they have taken advantage of it, and some of the interesting examples and case studies that are already out there today. So let's start with, a definition. Really, industrial symbiosis is a collaborative approach where different industries work together to use each other's byproducts, resources, energy, and expertise to improve resource efficiency and reduce or reuse or recycle waste, right? It plays a crucial role in a sustainable industrial practice. It is essential for promoting circular economy. I'm sure we've all heard of circular economy, right? And those principles, reducing environmental impact, enhancing economic competitiveness. Industrial symbiosis fosters innovation, creates new revenue streams through shared resources, and extracts more value from existing resource bases. So yesterday's waste is tomorrow's product in that sense, right? Sustainability. By fostering symbiotic relationships, industries can optimize resource use, minimize waste generation, mitigate environmental harm. This leads to long-term environmental benefits and contributes to the overall sustainability of industrial processes. So what are the key principles here? First of all, innovation, right? Encouraging innovation through cross-sector partnerships, leading to new product development, process efficiencies, and sustainable business practices. In addition, resource exchange. Industries collaborate to exchange materials, energies, water, byproducts, waste products from one process into a valuable input for another, right? So very simple example, right? Sheet metal operation, you're doing a stamping. The waste material from that stamping could easily be an input into another process downstream, whether it's a smelting operation or a variety of other uses for the waste sheet metal. Sometimes you can even create products from within that waste sheet metal if there's sufficient product or material there, right? Synergies, identifying synergies between industries to create shared value opportunities, such as co-locating facilities, right? How often do we see, for example, a battery plant next to a factory, an automobile factory? So these kind of synergies, co-locating facilities to minimize transportation costs, but also to perhaps share resources, and perhaps the waste of one industry can become the input to another. So some very basic case studies. Kallenberg in Denmark is a prime example where companies share resources like water, energy, materials, reducing environmental impact and costs, right? The symbiotic relationship has resulted in significant reductions in waste and energy consumption, showcasing the benefits of collaboration within a complex industrial ecosystem. Waste to energy programs in different industries demonstrate the potential of converting waste materials into valuable resources, highlighting the economic and environmental advantages of industrial symbiosis. Some of the environmental benefits, 40% reduction in waste, 30% better energy efficiency, 20% reduction in emissions, and 10% improvement in resource conservation. So all of these through recycling and reuse and repurposing the waste from one process into perhaps the input of another. From an economic advantage, obviously cost savings. Oftentimes waste is expensive to dispose of. So instead of disposing of it, put it to good use. So what was a cost center is now a profit center. You're generating revenues from yesterday's waste, right? Market competitiveness. If you can reduce your costs, you can become more competitive in the market, which will foster hopefully long-term growth. And then lastly, revenue generation. We're creating new revenue streams from old waste streams, right? So implementing this requires an assessment process where you're evaluating your processes and waste streams and the resources needed to identify those synergies and collaboration opportunities. You're communicating and collaborating with other industries through engagement. You're integrating symbiotic practices through integration. And then through evaluation, you're measuring and assessing the outcomes through various symbiotic initiatives, tracking performance and adapting strategies for long-term success. Some examples from my observed life, I guess, if you will. Henry Ford. This is a historical example with the Model T, but he actually used the packaging material, the crates that were being used by suppliers to ship parts to the Model T factory. Those crates themselves were reused as part of the product. So it actually became the floorboards for the Model T were actually the crates from the suppliers, okay? Subaru in the current day and age in Indiana is well known for having virtually zero waste factories where nothing is wasted and nothing enters a landfill. And they're very proud of that, but it takes quite a lot of work, both in engineering the process and engineering the product and the supply chain. Pineapple waste, and I'll be getting into this later in the presentation, is used to make fibers for textiles and vegan leather. Pullman, if you remember the Pullman plants in the south side of Chicago, building rail systems and rail cars for mostly passenger traffic, was very innovative, building houses for their employees, but they used brick from the local lake, which was which had to be dredged anyways for logistics purposes. So by dredging, all that waste material was turned into something useful, construction bricks, which were later used to build an entire town. That town can be seen today in the south side of, it's called Pullman. It's the Pullman neighborhood. Lastly, waste energy plants, as mentioned earlier, combined heat and power plants are added examples of industrial symbiosis. So if I'm producing waste heat because I'm producing electricity, right? Take that waste heat, capture it, and then distribute it as part of a heating plant. So you have combined heat and power plants, and you see that on campuses throughout the country. Where I went to school at UIC had a combined heat and power plant because of the physical geometry of the campus and because of the way the campus buildings were interconnected to each other. Sargassum, if you don't know what that is, it's a kind of a seaweed. If you've been to Mexico, to the beaches, you see in many parts of Mexico and Florida, sargassum covered beaches. This is more than an eyesore. It smells, it's a bacteria trap. It's quite harmful in many ways. It certainly harms the economy. People get turned off by it and don't want to return to those beaches. So sargassum, which was a nuisance / waste from the sea, and it comes in every day as part of the tides, and huge amounts are dumped onto the beaches on a daily basis, is now being harvested, right, and processed, as you can see on the left-hand side of this chart. Down at the bottom, you see it turned into a form of mulch. So you can use this to actually fertilize and cultivate your plants. On the right-hand side, it's a vegan leather. So they're turning it into vegan leather. And in the top middle, you see a construction product that comes from sargassum. So this one nuisance waste, on the beaches that are largely as a result of climate change, right? So we're seeing increased temperature in the waters, which generates more algae production, which creates more waste products onto the beaches, has now turned into multiple revenue streams and creating multiple industries in places like Mexico and Florida. I'm going to pivot to pineapple scraps. Why not? Because pineapple scraps have been used for centuries. The technique is basically used to extract fibers from the pineapple leaves, leading to innovative vegan leather and unique yarn opportunities. It's a versatile fiber, right? It's becoming popular in the fashion industry. It's eco-friendly, of course. It's got a metallic texture in some cases. The abundance and cultivation of pineapples globally provides a significant resource for sustainable fiber production, reducing waste and impact on the environment, right? So if you're interested in the company that's doing this, Pinatex by Ananas Anam, is turning now into a brand that is wrapped around pineapple leaves and pineapple waste products. So it's got basically some amazing opportunities. Life Pack is basically in Colombia turning pineapple crowns into compostable plates, right? So instead of making plastic plates or paper plates. Now we're seeing plates coming out of pineapple waste products. Um, Fuel Wrap, which is basically a biotech pioneer, is using pineapple peels in natural soaps and detergents, right? So fossil-free, plant-based, soaps and cleansers and detergents are now all the rage in the U.S. It's very rare that you see liquid soaps that are not plant-based. And there's lots of opportunities going into the future. So when you think about, where is technology taking us and how can it benefit the environment and how can you build new platforms and new product and revenue streams, certainly, this approach will certainly help, I think, create new opportunities in the future. So with that, I will see you in class.